Hello and welcome to CIO Talk Radio. To learn more about the show, please visit talkradio. And as always, we invite you to join the discussion on Twitter, hashtag CLive, and look for this show as hashtag fog computing. Today's topic is the rise of fog computing, and our guest for today's show is John Baekelmans, who's the CTO for Cisco's Internet of Everything Solutions Group. How are you, John?
I am very good. Thank you, Sanjog.
Very good. So, in terms of the fog computing, we know we are almost everyone is thinking and talking about cloud for some time, and there is some maturity that we're getting to it. People are no longer challenging whether we should go to cloud. We are saying how much and how to go about doing it. With all that happening, it looks like that it is not truly a panacea, and there are certain areas where there's an opportunity for us to put in yet another computing paradigm which would fill the gap. So that was interesting. And Cisco has actually pushed forward the idea of fog computing, also known as edge computing, in which that data might sit on the edge of the network and become a good companion for the cloud. And there's been a lot of discussion as of late with some real champions, but also there are quite a few skeptics. So that's where we invited you to talk about how Cisco is positioning fog computing or are introducing this concept, or is this something which is it is a replacement of cloud, or where is it going to create value? So the first question is, what's the genesis of this? Why should we even bother when we are up to our eyeballs with new computing paradigm that's cloud already?
Well, if you look at cloud computing, of course, cloud computing is not new. I don't know how many listeners out there who remember the 1950s when people actually used terminals to access the data out in these gigantic mainframe computers. We've come a long way since then. Connecting to the cloud is now typically commonplace. Everybody's using it. And so the innovators are looking for ways to complement the cloud as everything comes online in the next few decades. And that everything, of course, is the abundance of data which will be generated by what the main public called the Internet of Things and what Cisco called the Internet of Everything. Now, we discovered enough of barriers which might be hindering the rise and the further rise of cloud computing, and of those are, for example, the amount of bandwidth available in typically mobile networks, the latency which you typically will get if you have all these sensors going over a compute device or connecting to an actuator will actually have an end-to-end path. So that latency between those. And of course, the fact that once you start to connect things to the network, what's the sense of real timeliness you need to have some kind of reaction when there's some kind of action coming from those things. So lack of bandwidth, latency, and real timeliness is some of the issues we're seeing, which is going to be challenging this paradigm of cloud computing.
So you're essentially basing this whole new paradigm or introducing it, thinking that the bandwidth will have a choke point, where after some time you will simply not have enough bandwidth for all the increase that we will see, and that's where we will need something close to the edge, or where we can call it close to the ground. Is that the core of your proposition here?
That is the core of the proposition, and of course, bandwidth is of course one of the major issues. That is, like I said, the need for real time internet, the need for less latency. Because at the end of the day, if you look at it, who is ever happy with the speed they get, whatever they connect? So it's not going to be easier once we go further in time, because of course of the amount of things which is going to connect further to the network. We think and we predict 50 billion things by 2020. How are you going to scale by connecting all those things to the network and having all those things communicate directly with the cloud? That's the issue we're seeing.
So let's compare this to what organizations already have as on-premise infrastructure, or maybe a distributed set of data centers which are connected over metropolitan network or WAN or any other kind of connectivity, which is not truly taking them into the cloud. It is a kind of pseudo cloud of sorts, which they are using. And somebody would sit there scratching their head, okay, so I'm also keeping something on the ground. I'm also using some sort of non-cloud connectivity. So why even have the third type of paradigm? I might as well have a hybrid infrastructure where I have something on premise or something we own and run it that way. And the second one is cloud. Why do we need the third one?
Well, it's what we're seeing is that, and I think there is clearly time and place for hybrid models. Cisco doesn't have for nothing a new paradigm amongst that, which we call intercloud, where we connect typically on-premise with, for example, off-premise public clouds, and there needs to be a way to make that secure. But what you're saying is, if I already have a compute and storage infrastructure locally, and if I do some offline storage into the cloud, would I need something in between? Well, it all depends what the applications are. I think if you talk about a real data center, like kind of a private cloud, I don't see a lot of today applications where you would need a kind of fog computing infrastructure needed. Where I see it needed it more in places like remote places where you have typically a connectivity challenge, remote oil fields, places where pipelines you need to monitor, places which have a fast moving type of characteristic like transport, public transport, trains, buses, where basically connectivity is a challenge and where you don't want to rely upon that network in the connectivity to be able to take actions on the spot whenever they appear as they are. That's where today most of the use cases of fog computing will come into play.
Can you take us through a journey where you say that something is fast moving like a train and you're saying, or a bus or any kind of transport, and you're trying to adopt fog computing? It still has to connect something to somewhere where some data is exchanged with some central hub or some form of centralized computing in order for it to really create value. Otherwise, what is one train or bus or any other kind of transport doing by connecting with each other just like that?
So let's take the example of the bus. A bus typically going from bus shelter to bus shelter. Most buses today have an infrastructure from a security perspective. They have cameras on the bus. Drivers sometimes have alert buttons. But of course, the challenge with the bus is you have typically mobile connectivity from the bus. They might even give you some internet access from there, but you don't have the required capabilities to actually do live video streaming from the bus all the way down to the operations center. So what happens if the analytics on the camera, which of course cameras today are smart, they have analytics on board, analytics detect inside of the camera that something is happening inside of the bus. And now you want to first alert the driver locally, and then you want to of course alert the operation centers. But you don't have the bandwidth at that point in time to send that real-time data feed directly to the operation center. What do? Well, you try to alert the operation center with an urgent message. That's typically a small packet. And then you try to, of course, store, compute, and whatever you can do locally inside of the bus architecture and infrastructure. And then hopefully that alert button was used to alert a local type of perhaps security teams who come and then help you inside of the bus to take care of the particular incident in the bus. You have stored all that data, so you have got all the information available. And then once you get to the bus stop where you might have an kind of a transfer point or an access point, you might then be able to stream that data directly to the operations center. So what I'm trying to tell you is that even in locations or in places where there's less bandwidth available, the ability to have local intelligence on the edge is going to be much more important over time because of the amount of applications we're going to put inside of the network.
So in this example, I'm just trying to dig deeper here. In this example, if somebody was able to just send an urgent message, very small packet, with limited bandwidth, that was still possible because you still did not need that extended bandwidth for which
Correct.
we are justifying the need of fog computing. So that use case is even being implemented today without fog computing. What would have changed if you had the fog computing infrastructure integrated with that bus's internal security infrastructure? What would have been different?
Well, today you do not have all the capabilities at hand inside of a bus to do enough actions inside of that bus. You cannot take enough consecutive or material type of commands you would do normally if you would have just an alert button sending one packet to a central location. You might want to be able to, on top of that alert, open an audio communications channel. That audio communications channel then might have abilities to send at least the voice traffic, which typically is smaller versus the video traffic, to the operations center. What I'm trying to tell you is that by having the ability to have computing at the edge available, you can install applications at the edge where you kind of start to pre-filter and pre-take enough actions versus what you then typically would have done if you only have one connection to send just an alert to the operations center. If the operations center alert comes in the traditional way, the guy then has to call you back. The guy from the operations center has to call you back via a traditional analog radio. You probably don't have the time to open that communication because you're busy as a driver to deal with the issue. So all of the actions you can take from an automation perspective is what typically fog computing or the compute infrastructure locally in the bus would be able to take care of versus just the traditional, I have just an alert button in my bus.
Very fascinating for the use case that you mentioned. Now, in terms of the pervasiveness of opportunity that might exist, do you think such specific use cases are the ones where fog computing, of course, has as a need we can justify, but for the rest of us, maybe it's a business service or an e-commerce company or any other place where you are using cloud computing today, and maybe you have some on-premise or some of our own infrastructure available, does it have a compelling enough use case that everyone should consider, or would you say this is for a subset of the whole business world out there?
Well, what we do is we typically divide the world and the opportunities into what we call vertical areas. And every vertical area we see has enough, let me say, opportunities and capabilities where we see a clear advantage of going into a fog or distributed type of compute kind of architecture. Let me give you a couple of examples. For example, energy, everything around energy today is moving towards a smart grid where people either harvest energy at home via solar, via wind. And of course, there is the entire issue around what do I use best at which time, and how can I take using local intelligence, the decision to now inject my solar into the network, now use my wind, and so on. So to be able to have that local intelligence at a home or at wherever you actually use this type of capability is going to be important in such a smart type of energy environment. So smart grid certainly has enough opportunities also for the people and the home. Let me give another one in the city. Smart traffic lights. People have been thinking about it today. Traffic lights are as smart as the loops in the ground. So if there is a loop or a camera on top of the light, you might get the faster green. But what if that video camera, for example, can sense an ambulance flashing light so that it knows that an ambulance is coming? It helps to serve that the current light becomes green. And then, of course, through an application being available at the edge, you can then talk and pass that through the other traffic lights upcoming to ensure that there's a green wave end to end for that ambulance. So you start to see that even in simple examples like in the city and traffic lights, the ability for traffic lights to be a little bit smarter, to have the video camera use a little bit more knowledge to then connect 1 to 1 equals 3. An ambulance with flashing lights typically means emergency is something which is quite easy to implement today. And then last but not least, what we are very active in is in transportation, especially around trains which can monitor themselves, train components which can monitor themselves, and of course the ability that whenever they monitor themselves and they feel something is wrong inside of the train, that they detect the issue, they send an alert to the train operator, and they stop at the next station for an emergency maintenance instead of just waiting until the train doesn't run anymore or stops in the middle of somewhere else in the middle of between two stations. So there is I can go on like this. There is enough use cases across many different verticals. Of course, sometimes they're more business focused, but what I feel very clear is that because of the adoption of devices and connectivity from users, I think the biggest adoption will be first in the place.
Let's take a quick break. Listeners will be right back and explore this further. You mentioned that there would be some adoption on the side. And frankly, because is usually wary of adopting something brand new or something they should not actually care about if they're going to get a facility. And if it is compelling enough, they will pay for it. So it comes down to the total cost of ownership for the one who is provisioning that fog computing infrastructure. And of course, where will that money come from? And would there be a overall value proposition in terms of a positive ROI? So if it is not coming together, then people will not buy and it will be a loss-making proposition. So how do we create the business case in front of the people, including so that this actually sees the daylight and people truly benefit from this adoption? Please stay tuned, listeners. We'll be right back.
HP is proud to sponsor this program. Find out how the HP as a service solution for SAP HANA can help you gain instant, impactful business results without capital investment by logging on to hp.com. Transform information into intelligence and a competitive advantage with a full spectrum of SAP HANA products and services from HP, a global SAP hosting partner.
Bosch Software Innovations is proud to sponsor this program. Visit www.bosch-si.com/connected manufacturing to find out how Bosch can help you improve your operational performance and become a manufacturing industry leader in a connected world. Change the way you predict, manage, and produce outcomes. Bosch Connected Manufacturing.
HP is proud to sponsor this program. Tap into our expertise, innovation, and services to bring your most important workloads to the cloud. You are listening to CIO Talk Radio with Sanjog Aul. To learn more about the show, please visit www.ciotalkradio.com. If you have a question or comment, call toll-free at 1-866-472-5790. That number again is 1-866-472-5790. Now, back to the show. Here's Sanjog Aul.
Welcome back. So we did talk about some use cases, and before the break, you touched on the and wants a ton of things, and if they are provided the appropriate infrastructure or the responses, etc., then I'm sure they would be willing to pay up, because somebody has to spend money and somebody has to benefit in order for any new computing paradigm or any new expenses to be incurred by any entity connected to it. So let's go through this whole value creation ecosystem. So who is spending the money, who is benefiting, and how is the value getting created, which warrants some investments?
Very good. So it's a very valid question, of course. So fog computing, at the end of the day, we believe is going to be installed, implemented, and maintained by those people who have a need to ensure that with limited amount of bandwidth or with increasing needs, but not enough bandwidth, can still have enough use cases be made available to their end customers typically. And in this case, we could talk about it. So if you look at it, if I'm a service provider, I'm installing my infrastructure into the streets to give them connectivity. And I need to make sure that I give them enough connectivity for them to keep them happy as to the level of connectivity from a speed perspective, from a performance perspective, and so on. I sometimes have to have trade-offs where I will run the intelligence in the end-to-end architecture. And if you can offload some of that intelligence or some of that performance into closer to where those are, if you can offload some of that, closer to where the action is, so that their traffic doesn't have to go over the network end to end, over all the way down to the cloud and back from the cloud, you're winning. Because you're winning, one, because you're freeing up your backhaul network to do other things and to serve more customers. And at the same time, you're also freeing up CPU and storage in your cloud infrastructure to possibly serve more customers. So it all depends who is the beneficiary from the service delivery, and of course, who is delivering the service. So it really is a question of, if I'm a city and I'm installing smart capabilities into my city, I'm installing smart infrastructure, how much applications at the same time could I run at a crossing to serve the traffic lights, to serve smart traffic, to serve possibly other applications at the edge of the network, versus having to serve them one by one from the cloud. And that's what I think is going to matter. That's what I think the ROI needs to be calculated on a case-by-case basis. You can't generalize this across the board.
So would you say, like, say, city government is one possible adopter for this, and then maybe a large retailer like Walmart, if they are having their fleet and they want to have their own management and a better control on how their warehouses are being connected with their drivers, and how the goods are moving in their whole transportation system, maybe they could be the other type of adopters. Are there any other types that you can inventory here?
As I said, I think we see a lot of adoption initially because of course, the issue, of course, is that are typically a little bit spoiled by the amount of access and bandwidth they get into their homes. If you then get to places where you don't have that bandwidth, but you still want to have enough of actions available within your work set, as I said, offshore oil rigs, pipelines, all these places where you're typically being served by less than broadbandish type of internets or networks, that's where you typically will see the adoption first. And that's where we're also focusing on initially, because those people are really demanding much more, let me call it, predictive maintenance capabilities, much more actionable items, much more analytics capabilities, much closer to where the data is being generated. Remember, the issue is about data generated. The issue is about the fact that today we are generating about, I think the last thing I read was 2 exabytes of data, and 1 exabyte is a billion gigabytes. So if you see that being generated every day, if you see a plane engine generating 10 terabytes per half an hour, how do you deal with that data? You can't send all that data across from a plane, from a satellite link. You need to deal with it. You need to try to deal with it in a much faster way. And that's where I think the initial adoption will come from, on a case-by-case basis. And of course, what we're then trying to do is, by way of implementation, is we have created a platform where that platform actually allows for you to run enough applications at the same time. So you can run different types of use cases into your edge environment for different type of vertical activities.
See, whenever a new paradigm is introduced, people are skeptical and they have the right to do so. So if a platform is put out by a provider, then definitely they have put in all the efforts, and yes, they have the right to get the returns on that. Now, in terms of the very platform that you're referring to, it is a technology, or maybe there are some ways the way you are manifesting that to make this whole fog computing happen. How open is it for anybody else to come and say, we also want to offer it as a provider, and let that be adopted for a common good? What's the story there?
That's a very good question, and we have been looking at that for a long time, and the reason for that is very simple. With the rise of the Internet of Things, what we call the Internet of Everything, it's very clear that you now have to connect a whole new slew of different interfaces and protocols. And as a vendor of technology, you can never innovate that fast to be able to integrate all these protocols and new interface and the modules as fast as the market wants you to do. So we had that challenge, and we said, how can we solve that problem? And at the same time, we said, we want to make sure that we create something which is open, like you said, and which allows people current implementation of applications actually to run on the edge of the network. So we basically came up with a combination where you can satisfy your communication needs, your computing, and your storage needs into a single platform, typically for application enablement. And we call this IOx, where we combine our Internet Operating System, which we call iOS, and together with the best of breeds, we believe Unix operating system called Linux. So, and iOS plus Linux, we call IOx. And more than a software platform, we also allow partners or anybody using the IOx capability to bring their own hardware interface so that they can keep on running their specific interface and protocol. So we basically created a generic interface module where third parties can actually plug in their specific interface hardware and can run their specific protocol. And on top of that, into the Unix environment, which is open, standard, they can actually run their own application. And with that, we created some kind of, and we call it bring your own interface, bring your own app type of methodology. Of course, a little bit looking at the bring your own device type of analogy. But so it allows, we believe that by creating this open hardware/software interface, and then by offering APIs from the network or the communications capabilities from the devices we typically put in networks, we think we have given it a very first good go to be able to allow it to be as open as possible, to be as standards-based as possible, because Cisco never wants to lock people into certain capabilities.
Let's take a quick break, listeners. When we come back, let's look at the proposition that you're putting out. And of course, you would like organizations to adopt these solutions and purchase and invest towards it. What is the pushback? What are they saying is either not their need, or there is a disconnect in the way it is being envisioned versus what they are looking to do? Or is there any knowledge gap because of which it is, I mean, of course, it's new, but the rate at which you would like to see this adopted, given the explanation you provided, I think everybody should jump on it. But if they're not on it, is it the typical skepticism against any new paradigm that is proposed, or there is something more to it? What is the potential thing today for adopting POC computing? Let's explore that. Please stay tuned, listeners. We'll be right.
HP is proud to sponsor this program. Tap into our expertise, innovation, and services to bring your most important workloads to the cloud.
Bosch Software Innovations is proud to sponsor this program. Visit www.bosch-si.com/connected manufacturing to find out how Bosch can help you improve your operational performance and become a manufacturing industry leader in a connected world. Change the way you predict, manage, and produce outcomes. Bosch Connected Manufacturing.
HP is proud to sponsor this program. Find out how the HP as a service solution for SAP HANA can help you gain instant, impactful business results without capital investment by logging on to hp.com. Transform information into intelligence and a competitive advantage with a full spectrum of SAP HANA products and services from HP, a global SAP hosting partner. You are listening to CIO Talk Radio with Sanjog Aul. To learn more about the show, please visit www.ciotalkradio.com. If you have a question or comment, call toll-free at 1-866-472-5790. That number again is 1-866-472-5790. Now, back to the show. Here's Sanjog Aul.
Welcome back. So when we see any new computing paradigm, there is skepticism. And as you go about talking to the various potential prospects who could benefit from it, they may be looking at it with some stigma attached to it or some other concerns or reservations. What are those? Let's put them on the table.
Clearly, I think the cloud and the rise of the cloud, but certainly the cloud and many cloud providers provide it almost at no cost. So it is very easy today to do anything on the cloud. It's very easy for me as a startup to come up with a small sensing device, to create a small application around it and put it on the cloud. It doesn't cost me a lot to actually do that, which is great because it helps with innovation. It helps with a lot of the things we're seeing and helps with the speed of innovation we're seeing today. So certainly that is an issue. Secondly, I think we haven't reached the critical mass yet where people start to see that sending everything to the cloud is not going to happen. It's not going to happen. It's not going to fly. So certainly that combined with it's cheap to do everything in the cloud. The cloud still has enough CPU and processing power. Is something which is certainly hindering people or could be hindering people to not adopt fog or edge computing at this point in time.
So would you say there is a light at the end of the tunnel? There is a specific type of either a compelling business case that should be created or something should happen which will open up a few eyes and you feel this would see the daylight in the desired degree of adoption?
We see, yes, we see the daylight already in certain areas, like I mentioned before, the places where that connectivity is not so ubiquitous, that connectivity is not so large. That's where we see the opportunity for, because those people really are grasping to anything they can do to handle that terabyte of data coming from that oil well in real time, much more closer to where that oil type of data is being generated. Having said that, if you, of course, look at the large adoption coming typically from a place where service providers or other people like infrastructure providers in cities will start to use cloud computing or cloud computing, we typically think that it will take a little bit. I think we're going to have to see a little bit more challenge around one, cost of bandwidth, or two, amount of connected devices. Those will basically dictate when you start to see a challenging arising on, I have to do something else than sending everything to the cloud, because now the turnaround time to send, compute, and send back is taking too long. I have to do something else. Otherwise, I'm not going to be able to do a particular transaction in the amount of time I need to do it. So that's what I think it will take.
When you talk about cloud, you look at one is the deployment model, which is a private or a public or a hybrid cloud. And when you look at the service model, you've got infrastructure as a service, platform as a service, software as a service, etc. Are there corresponding adoptions or you could say service models and deployment models that you envision for fog computing?
All of the above. I mean, everything you mentioned, I think, really applies in fog computing. The way we go about trying to get fog computing being used across a number of verticals is creating an ecosystem of partners. And those partners typically are partners in many different areas, typically mostly in industrial areas, where they have challenges today in factory plants and so on, which they couldn't solve before, where through the use of computing, they can now take that on. So, but then the model to actually use the same for their customers, or in the cases where those partners are technology vendors as well, they will typically use an as-a-service type of model because it's easy, fast to deploy, and the only thing they need to deploy basically is a software application on top of perhaps an already existing device at the edge of the network. So if you talk about software and if you talk about deployment of software, the as-a-service model, the as-you-go type of model is clearly a model which I think will go very well over time.
So in a way, what you are trying to do here is while on one hand, you might go to a city and say, let's adopt fog computing and it can do these great things. And if there is a pushback or there is some other kind of concern, do you think it is better to leverage a partner network who may already be embedded with the city or with another transportation unit or any other vertical that you're trying to target. And since they would be able to anyway benefit and be able to serve the customers well, then the goal is essentially to get this to become a backbone for all things that are being done by that industry provider, or you can say an organization within that industry. So are you supposed to go and directly hit a city, for example, versus working with another utility provider or someone else and say, okay, why don't you use it? And that way they get a flavor of what this is like. And then maybe some other use cases will be easier to put in front of them and convince them.
At the end, that's a very good question. At the end, the customer is always right. The customer always will tell you with who they want to partner, with who they want to connect. And we believe that in this landscape of the Internet of Everything, you can't do anything alone. You have to partner. You have to partner with the rogues. And perhaps if one of those companies is a utility which has been working with the city for the last 25, 30 years, why would you then try to push them away and try to come up with another partnership? If you can work with that partner and you can actually make their infrastructure a little bit smarter, and you can achieve whatever you want to achieve over time, working together with them. So working in partnership in the landscape of the Internet of Everything is something we've learned to do because the landscape is way too big. The amount of challenges you have are way beyond your comfort zone, and you need to work typically with companies who have been there and who might serve a little bit different market, but at the end of the day, who will also benefit in their particular market by being able to use that same edge device to put some more applications closer to where their action is actually happening.
So whenever we look at any new paradigm, of course, you're presenting it, it definitely has the potential to evolve. Where is it not fully cooked? What it cannot do, which you think in due course it will be able to offer to the potential customers?
I think if you expect today the power, the compute power, and certainly also the storage power of what you typically have available at the cloud, we're certainly not there yet. The devices you use at the edge are typically gateway devices, or what we call their routers or gateways or switches, or even cameras where you can run inside of the camera, you can run under applications. But the size of those devices does not allow you typically to put in so many terabytes of storage or so much MIPS you need or you typically have available inside of your cloud infrastructure. So clearly you need to decide what you want to run on that edge network. What do you want to do? What do you want to achieve? Do you want to pre-filter? Do you want to use some analytics capabilities? Do you want to apply security capabilities at the edge? It all depends on really what you want to do. You need to actually decide. You can't run your entire cloud application, let me say, into your edge infrastructure. So one does not replace the other. There will still be, as far as we can see it, a combination of the two. And the two go hand in hand. The two have a different role to play, and the two have a different footprint as well.
So in a way, this is interesting the way you mentioned that the devices are not yet ready to be able to harness the power of fog, which you may have already offered. So is there some waiting period, or is fog computing too early for it to really be able to show value? Because if the devices where you want to do the computing or the ones where you want to do data transfers, etc., if they're not ready, then the overall end magic that you're trying to show, there is some wait time there. Or do you think that you are creating a new industry in a way by which the devices, the type of devices which are currently being used as a traffic light or whatever else, that fundamentally will need to shift to be able to do that huge terabytes of data transfers and many other intelligence computing at the device level for your platform to be able to deliver value?
What I didn't say is that we're not ready. There is capabilities today available. There are enough hardware devices available where you can run fog computing today. What I would say is that they don't have the amount of processing power, the amount of storage capabilities you would typically have if you would only do cloud-based interactions. That's one. And they will improve over time. There is a roadmap for that. They will improve over time, but of course, it also depends upon what customer demand from a size perspective. Typically, these devices live on the street, so they need to be hardened, they need to be ruggedized, they need to be aesthetically pleasing, so you need to see what you can do. So having said that, yes, we are creating a new industry, and yes, we are trying to indeed create an ecosystem where other players in many different industries can actually go and apply the same type of principles of fog and edge computing, and where we are certainly at the starting point of a number of things happening there. But as we discussed earlier, some people in some industries don't have the needs yet or didn't see the need yet to go into the fog paradigm. Others clearly do. It's with those others we're working first to, of course, improve and make sure that we harden the technology and the platform and the framework, and then, of course, bring it to a bigger type of a mass adoption into areas like cities, into areas like service providers, and so on.
Let's take a quick break. Listeners, will be back and talk about the ability for an organization to adopt fog computing. So when we look at cloud, we say, yes, an organization who has which has on-premise infrastructure, and then they have to identify which application and infrastructure they would like to move to the cloud, and they start splitting out what they have on-premise and in cloud is when they are ready to go there. When it comes to fog computing, how much of a readiness check that an organization needs to perform before they can say, yes, we are ready to adopt fog computing, especially if they are already on the cloud bandwagon. Please stay tuned, listeners. We'll be back and explore.
Bosch Software Innovations is proud to sponsor this program. Visit www.bosch-si.com/connected manufacturing to find out how Bosch can help you improve your operational performance and become a manufacturing industry leader in a connected world. Change the way you predict, manage, and produce outcomes. Bosch Connected Manufacturing.
HP is proud to sponsor this program. Tap into our expertise, innovation, and services to bring your most important workloads to the cloud. HP is proud to sponsor this program. Find out how the HP as a service solution for SAP HANA can help you gain instant, impactful business results without capital investment by logging on to hp.com. Transform information into intelligence and a competitive advantage with a full spectrum of SAP HANA products and services from HP, a global SAP hosting partner. You are listening to CIO Talk Radio with Sanjog Aul. To learn more about the show, please visit www.ciotalkradio.com. If you have a question or comment, call toll-free at 1-866-472-5790. That number again is 1-866-472-5790. Now, back to the show. Here's Sanjog Aul.
Welcome back. So when we talk about readiness and for any new computing paradigm or any new way of doing it, we have to see if an organization is ready with what they want to do and if their current infrastructure and the way people are working on it is not going to fundamentally create a disruption when we go about onto a new computing paradigm. So what is it with fog computing that people need to check before they say, okay, it's a green light, let's go?
So I touched a little bit on it. We try to make it as easy as possible from a transitioning perspective to transition. And perhaps it's the first step for you as a company or as a technology company in the world of IoT or IoE. So it's basically twofold. Either you have this kind of exotic protocol you need to support on some kind of hardware interface. I told you that we make it quite easy, and we have a playbook and even a cookbook on how to generate that particular interface card you can plug into our Edge platform. And on top of that, now of course you can run a standard Linux application inside of the device. So you can, with that application, you can of course interact with all the data going to the device. So we of course publish enough APIs available for people to interact through that application running on that Linux kernel inside of the device. And basically what you need to ask yourself is all the time, which are those type of interactions I'm doing from my sensor or with my actuator or whatever your application is, which need more real time, which have a real time nature, which have a low latency characteristic. Which data don't I want to send over the entire backhaul network to the cloud, which can stay local? What data do I want to store? So you need to basically think in a way that what can I handle locally versus what I want to still store in the cloud, perhaps for big data type of analysis. That's the type of discussion or need to make for yourself. But we believe that we made it as simple as possible to actually make the move from, let me call it a pure cloud player to more of a combined fog cloud player.
Let's look at the people side. So many times, while you might have a fairly mature technology to put in there, but in order for us to maintain and or upgrade or anything else that you have to do with it, you need to have some specialized skills. What is your newer skill requirements from the folks who will be working within an organization for which you will be deploying fog computing? And where are the gaps?
We believe none. If you were aware of our equipment already with regards to user interface and so on, and if you were aware about Linux and the Linux environment and typical VMs in the Linux environment, you're basically ready to go. So you don't need a week of training to actually understand how this works. It works basically out of the box. The APIs are very clear. And of course, if you want to start with this, we also have a way to help people getting started. So we can even do some testing of your application, of your hardware, because of course, we also want to help you to then scale your particular application into perhaps other partners we have around the world. And that's typically the benefit of playing with a vendor like Cisco. So we try to make it as simple and as easy as possible by applying, we believe, the most available operating systems, either from the network perspective or from a computing perspective as such.
So that is about your platform. Now, your platform coexists with quite a few. Earlier, they were devices. Now they're supposed to be smart devices for them to be able to help or get the help from the fog computing environment. So the people who are currently working with the technology infrastructure alone, and if they are given 20 different types or maybe 50 or 100 different types of newer types of devices, and what is happening on their end and their maintenance and their upkeep, does that add more to the already spilling plate? It's not just the fog computing platform itself, but what else will they inherit just because now you're making many other things smarter, which by design then fall within that same crew for them to manage?
We believe and we hope that if you make things smarter, then you also increase efficiencies and that you also make it cheaper. That's what we believe. That's at least what we want to do by allowing people to run applications in the network. Instead of having to buy separate servers, a separate infrastructure, separate cooling, now you use one device to do it all together. And I would hope that the people who then use either their sensing environments or their applications on top of the network infrastructure do it in a way that they increase efficiencies. That's the entire goal of this. If not, there is a problem, clearly.
So there is no more work or more variety of work getting created because an organization is adopting fog computing, because that will be a pretty tall claim to say we fundamentally make your environment smarter and you do not have to do anything more than you were doing earlier.
And that's what we believe we have created, yes.
If that's the case, then I'm buying. So that is awesome if that's what's happening. But it is still, of course, the jury's still out and people are still testing. Now, final thing, any of these initiatives require a leap of faith, a sound leadership at all levels for this to become, of course, get this adopted properly and also see it to completion and value creation so that people say, yes, their investment was well worth it. What do you think people need to keep in mind? What's your appeal to those folks who are out there who are either making a decision towards this or they're influencing it so that they look at it objectively and make a decision which will serve them well?
Yep. So I think you clearly need to decide for yourself whether today is the time to actually adopt fog computing. And the question is clear. Am I challenged today in my operations from either a bandwidth, a latency, a real-time perspective? Or could I, if I increase one of the three, could I increase efficiencies of my business? And if the answer is yes to one of the three, I think fog computing could be for you, because you can, by allowing at the edge of the network to become smarter, you can increase the efficiency of your operations. That's exactly what we're doing. We're not trying to sell boxes here. We're trying to create improved business outcomes, because if you try to sell boxes in this space, you're not going to get far. You really need to ensure that the entire use case end to end and that the ROI gets satisfied with what you're trying to do. So you need to make your decision based upon that analysis. And if that analysis turns a yes in one of the three, then you are a good candidate for fog computing. You are a good candidate to put more intelligence at the edge, to save some money on your backhaul network links, for example. And you should be looking at this very clearly. And then we are ready to talk to you. We can see how we're going to do it. And we have enough use cases available to actually show what others have done in the world in many different areas.
On behalf of the show and our listeners, I'd really like to thank you for sharing your thoughts and enlightening us on what this fog computing platform is and how is it going to hopefully create value for the world out there, the businesses, the commerce, the healthcare, the citizens, everybody else combined. So thank you so much.
Thank you for having me.
Thank you so much again. Listeners, please like us on Facebook, search for CIO Talk Radio, and be sure to follow us on Twitter. Thank you again for listening to CIO Talk Radio. This is Sanjog Aul, your talk show host. Till next week, take care and God bless.